Hey everybody, today we're doing compositions of functions. So today our goal is to perform composition of functions and identify the domain for the function. So let's review. So when we talk about evaluating functions, that's really all we're doing today. So if I ask you for f of 1, now my input is 1. In this function, my input is x because I could change that to anything. That's why we have x there. So I'm plugging in x, so it gives me 3x squared. So if I want to do f of 1, that means I'm going to do 3 times 1 squared. Right? All I'm doing is substituting in 1 for x, so that just equals 3. Now, if I do f of negative 2, well, I'm going to be doing 3 times negative 2 squared, right? Because that's my function. So negative 2 squared is 4 times 3 is 12. Okay, we call 3 and 12, those are our outputs, but we're focusing on the input. So here I have f of delta, or triangle, right? So that's no different. I'm just changing my symbol. So now instead of x, right, what I've been doing this whole time is saying, well, I have this 3 and I have this squared, and what can change is x. And this time I'm going to change it to a triangle. So 3 times triangle squared. Okay, it's not always going to be a number. But again, this 3x squared, so I have 3 times my input squared. And that's what I'm changing, right? I plugged in a 1 there, I plugged in a negative 2 there, I plugged in a triangle there. Now I'm going to plug in x plus 1. Okay, so now you have to be careful that you remember all of the algebra that you've learned, so you're doing these right. So this is 3 times x plus 1 times x plus 1, right? That's what that squared means. So I'm going to FOIL that out. So I get x squared plus 2x plus 1. And then I'm going to distribute the 3. So I have 3x squared plus 6x plus 3. Okay, so for all of these, for f of x, I had f of something is equal to 3 times something squared. Okay, that was for this specific function. And we're going to use that idea as we move forward, because now when I say composition of functions, I mean that I'm going to put a function, another function inside here. So let's do example 1. Okay, so f of x is 2x squared, and g of x is 3x minus 1. Find the following and state the domain. So remember that we need to find the domain of each of these. Well, remember they're always all real numbers, and my two exceptions are an even root and a fraction. And I don't have either of those in either of these. I know 2 is an even number, x squared, but it's not a root. It's just x squared. So when you do f of g of x, so you're doing f of something equals, and what you're plugging on the inside is g of x. So what is g of x? Well, g of x is 3x minus 1. So ultimately, I'm putting g into the function of x, right? G's on the inside, so g is going into f, where x used to be. So f is my outside function, so my outside function is 2x squared. So a 2 times something squared, just like we did before, but now on the inside, I get to put g of x. So g of x is 3x minus 1. Because if I write this up here, f of 3x minus 1, because g of x is 3x minus 1. Alright, so maybe that's a better way to write it. So now that I've plugged g into f, I do have to simplify this. So that's 2 times 3x minus 1 times 3x minus 1, right? That's what that squared means. I'm not allowed to put it on the inside. Write it out twice always. So then you have 9x squared minus 6x plus 1 after you FOIL it out. I'm assuming that you know how to FOIL here. Then I'm going to distribute the 2. So that's 18x squared minus 12x plus 2. And my domain, again, I'm using f and g here, so I have to combine these domains, which is just all real numbers. Okay. So once you have that written down, we got to do part B, and we do really need to pay attention here because this is brand new stuff. So now my inside function is f. So I'm really doing g of, well, f of x is 2x squared. Okay, g of f of x is 2x squared. So now my inside function is f. So I'm taking f and plugging it in to g. But let's write my outside function. So my outside function is g of x, and that is going to be 3 times x minus 1. Right? All I'm doing is basically taking out the x, and then in its place I'm going to put 2x squared. Right? And this is just like we did before, where we substitute in for x, but now my only different step is that I have to substitute in the actual function. So g of 2x squared means I need to plug 2x squared in for x. Everything else stays the same, like the 3 and the minus 1. And then I have to simplify. So 3 times 2 is 6, x squared minus 1. And my domain is all real numbers. Right? I have to combine both, just like I did in part A, which are both all real numbers. Okay. Example 2. So again, this is new, and it really just does take practice. So part A, I'm doing g of f of x, which is the same as g of f of x is 2x to the 1 half. Okay, and let's talk about the domain. So the domain of f, all real numbers, I'm going to write it on the other side. Actually, I'm going to start over. The domain of f is all real numbers, except for that is an even root. That 1 half is an even root, so I know that x has to be greater than or equal to 0. G of x is just 4x squared, so that's just all real numbers. Okay, so g of f of x gives me g of f of x is 2x to the 1 half. So then I need to plug in 2x to the 1 half into g. So remember, that was 4x squared. Let me write it down a little bit lower. G is, my outside function is 4x squared, so I need to plug in 2x to the 1 half on the inside. Okay, so now I have to simplify. So I have, this time I'm allowed to bring the exponent in because I'm multiplying on the inside. So I have 4 times 2 squared is 4. X to the 1 half times 2 is just 1, right? Power to a power, we multiply the powers. So that would be 16x. And again, I used f and g in this equation, so I have to use the domains of both. So that would be all real numbers, x is greater than or equal to 0. Okay, so here I have f of x. So now I'm doing f of x is 2x to the 1 half. So the outside function, I usually write this one down with just parentheses, so 2x to the 1 half. So let's think about this for a second. I am taking f and plugging it into itself, where x used to be. So the 2 and the 1 half have to stay, and now my input is 2x to the 1 half. Okay, so again, you're taking away the original x, you have to take it out and then put something in its place, right? You're changing the input. So now I'm inputting f of x into f of x. Okay, so now I have 2 times 2 to the 1 half, x to the 1 half times 1 half, right? Power to a power, multiply the powers, that's 1/4. So now these have the same base. That has an exponent of 1. So the base has to stay the same. And then you add the exponents. That's 3 halves. X to the 1/4. Okay, so my domain, again, is just a combination of both functions that I used. X is greater than or equal to 0. All right, so I know this is new information, so make sure you're writing down any questions that you have and going back and rewatching any portion that you need to, and we'll see you in class.